Hi friends, welcome to WebChamp. In this video, I'm going to discuss what is a normalization in database. So if you are preparing for the SQL developer interview, so obviously we are going to store the data. So how you can organize the data, how you can manage the data into the tables is what something related to the normalization, or normalization means organizing the data in the database, but for what purpose? So to reduce the data redundancy and improve the data integrity. Okay. So meaning we can definition is very simple. It is a process of organizing data in relational databases to reduce the data redundancy. Data redundancy is nothing but the chances of duplicate data. So your database should not hold the duplicate data, so it will consume unnecessarily. It will consume the memory, and that's what we have to save. So this can be achieved with the help of normalization, and to improve the data integrity, whatever the analysis you will do, whatever the uh, query you will perform, so that should give you the proper result. So it involve dividing large tables of the database into smaller one. So how normalization works? So if you have a table, so that can be divided into the smaller then related tables, and defining the relationship between them to minimize the data duplication and ensures the data consistency. Right. So this is about the normalization definition and purpose. But the goal of normalization is eliminate the duplicate data, ensure the data dependency makes sense. Obviously, whatever the relationship you will create between the table, that should make a sense. Then improve the data integrity and consistency, and simplify the data maintenance. Now let's take an example of one of the e-commerce business, okay, where the RDBMS is used. So there are many entities. Obviously, with the business has the many entities. So here, so let's say customer ID, okay, customer name, customer name, then customer address. Like this, we have a table. Maybe customer contact and any other details if required, you must have filled. So all these four columns are used for the customer related data, right? Then this customer must have selected a product for the order. So again, it will start with the product ID, product name, then product description, then product category, and product segment, like this. Okay, somewhere I said prod, somewhere I said product. So let me change this. Prod, and this is right. So these are the two entities we are seeing here. Product is done. Then orders. So obviously before that, some who is the selling this product. So let me say seller ID, seller name, seller address. Right. So like this, we will have the details for the sellers also, right? And then by considering all these three entities, our business runs. So we can put the order, order number, order date, then we can, so already most of the details are already here, we have picked. So order number, order date, order amount, expected order delivery, delivery date, right? So this is how we have the data. So if you hold all the data, let's say one customer can put orders for many product, right? So every time, meaning let's say this is 1 2 3 4 5. So one customer has ordered 5 products. For each customer, sorry, for each product, customer will be same. Just assume that, okay? So your data is getting duplicated here. Your data is getting duplicated here. Seller may be a different, right? Seller may be a different. And then order date, or order details. This is fine. So this, let's say this is this data is always with transactional data, so we can have the unique data for each row. Order number should be. But customer details, if you are, if you say like this, or we can say that the another customer has ordered same product. Maybe customer number 3 4 5, they must have ordered same product, one, like, okay. So now in this section your data is getting duplicated, your data is getting duplicated, right? So to avoid this, see, if your data is getting duplicated, that means that table is going to consume a large memory, and that's what we don't want, right? So that's why we have to do a normalization, so that data redundancy should be removed or trimmed. We need not to have the duplicate data, okay? And this is where normalization start. Now, so normalization is achieved. How we can achieve that? Through a series of steps that is called normal forms, and which progressively improve the structure of a database. So you have to go through the multiple phases of normalization, and then you will be able to say that this is a normalized one. Okay, and your data is consistent. You can say the data integrity is achieved. Like this, you can make the statements. So let's discuss about the normal forms. First normal form, what it says. Okay, all columns contains atomic values, right? So if you look here in this table, if there is a table which there is a table which has a column which is going to hold a multiple values, this should not happen in the database. You cannot add multiple values like this by putting the comma, slash and all. So don't do, or don't add the data like this in the database. So instead of that, what we can do is we can create a new row for each comma separated value. Okay. Each column contains values of single type. Okay, this is a basic requirement, obviously. So if you create a column for the integer number, so it should houses integer numbers only. Each row has a unique identifier that is called primary key. So for each of your table, you should have a primary key. So if you ask me here, or if we hold the data here, we will not be able to decide what will be the primary key. So order number, obviously this will be different. So based on this, we can define the primary key. But yes, for what about the customer details, what about the product details, what about the seller details, so we won't be able to do. Why? Because it is getting duplicated, and that fails the primary key constraint, right? So when your database satisfies the all the three terms or three conditions, then we can say that our database is in first normal form, not in normalized state, but it follows the first normalization or first normal form. Okay, so the atomic values, that means you can simply say that there is only one value in each cell. In each cell. That's it. The next is second normal form. When your database is in first normal form, then only you will be able to achieve the next level of normalization, that is second normal form. So what it says, all non-key attributes. Non-key attributes. Okay, this may be a confusing for the people's. Non-key attributes meaning we have different types of keys. Out of that, we mostly deal with the primary key, foreign key, unique key, and composite key. Okay, so the columns which are not considered as a key, those should be fully functionally dependent on the entire primary key. So now problem is, you can see in the table here, no partial dependency. So this statement you can customize as per your language in your wording, but yes, the meaning should be same. In short, I can say the columns which are not considered as a key, or we cannot make that them as a key. So those columns should be completely depends on the primary key column. The problem here, if you see in the same table, this is what I was trying to tell you sometime before, that student name, course name, and instructor. So all these three information, meaning instructor information, instructor is associated with the course ID and course name. These two terms are associated, right? Then student ID and student name. So there is no dependency of course details on the student, right? So course name and instructor are depends only on the course ID, obviously, but not on the complete composite key of student ID and course ID. Right. So in this scenario, what we can do is we can go and we can create more tables. Okay, so let me go to the next. So here you can see how we can achieve the second normalization form. So if you look at this table, all the columns was in the same table. So we splitted this table into the three different tables. What we did is first we created a separate student table. This is fine. So student ID and student name is extracted. Then course ID, course name, and instructor, this is even fine. Okay. And then enrollment table we have created separate, meaning based on these two. The way I said, seller, product, and customer, based on these three entities, the transaction is happened. Similarly here, based on the student details or student registered details and available course details, enrollment table can be created. Here it will just save the information about the student ID and course ID. Rest of the information is available in the respective table. So what will happen? Unnecessarily, we were holding the data of student names, course name, and instructor details in this table for each row. Here you can see that I have only two rows for student details. I have only two rows for this course table, and then three rows because here obviously we should have the a duplicate data in the business table. We can say this is a business table or transactional table. So this is not a transactional information, but still yes, we can say, because this table gives us the idea of who has purchased what, right? So this is how we made a split of the table to achieve the second normalization form. Second normal form says non-key attributes should be fully functionally depends on the entire primary key, right? So now, once your table is in second normal form, still we have not reached to the normal state of the database. We will go for the next normal form, that is third normal form. If your database is in second normal form, then you can go and apply the one more rule to achieve the third normal form. That is, there are no transitive dependencies, meaning non-key attributes should not depend on the other non-key attributes. The table, if you look here, is okay, right? So okay, so once your yes, so your table is in second normal form, so we have reached to this stage, right? So then we can make a one more split to convert third normal form. So there is a transitive dependency where the instructor determines the course name. Instructor determines the course name. So if you look here in the this table, the course ID, course name, and instructor. So this is again meaning instructor is depends on the course name, or we can say that the instructor is aligned with the course name. So this is again transitive dependency. So we should not have this kind of data in the table. So to avoid this, what we can do is our enrollment table is already separated, right? So student table is already fine. Course table, we will split into the two different table. This course table will hold only information about the course, like course ID and course name. And we will create one more table, that is instructor table, that is course ID and instructor, right? So based on this, we can do a mapping, or we will be able to find who is the instructor for which course. And this is how we can achieve the first three normalization form. Then what if your database follows the first three normalization form? We can say that the database is in normalized state. Still we have more normalization forms, not the BCNF only, but yes, more than that we have, but that is not important. Okay, if you you are able to normalize the database up to the third normalization level, we can say that your database is in normal state. Then what next BCNF says? So BCNF stands for Boyce-Codd normal form. So if your database is in third normal form, then the next rule we can apply, that is every determinant is a candidate key. Okay, if X is Y, then X should be the super key. Every determinant X is Y, meaning if Y can be derived from X, then X should be your super key. So here, if you look in the table, that course ID and instructor aligned with the student ID. So this table is again not in the not following the BCNF normal form or BC normal form. We can say Boyce-Codd normal form. Okay. So instructor determines course ID, but instructor is not a super key. And what kind of fix we can do is we can split into the separate tables to ensure every determinant is a candidate key. So again, we will have the two different table. One is course table that will hold the information about the course ID, course name, and instructor. And we will create one more table, that student enrollment table, student ID and course ID. Right. So this is how, but this is not that much important. So as I said, if your database follows the first three normal forms, we can say that database is in normalized state. So this is all about the database normalization and how we can achieve the normalization and for what purpose we have to do that is what I discussed in this. So when someone asks about the normalization in interview, so you should speak about the definition of normalization. You should speak about the purpose of normalization. You should speak about the different normal form, how we can achieve that, right? So I hope you like the content of this video. Thank you so much for watching the video. Have a nice day. Happy learning. Please do not forget to subscribe webcam.